Okay, so we've looked at solving systems of equations. Now we're going to jump into looking at systems of inequalities. So we're going to take a real quick review of graphing inequalities like we did in our last chapter, and then talk about what that means when we're solving a system. Now, if you remember, when we were doing equations, you would end up with a finite number of solutions, and inequalities have an infinite number of solutions. So in order to determine if a point is a solution to an inequality, we're going to plug in the point in for x and y and see if it makes it true. So in this case, I'm going to say 5 times 3 minus 3 times 8, and I want to know, is that in fact bigger than or equal to 10? So I've got 15 minus 24, which is not bigger than 10, so this is not a solution. Okay, let's try the next one. If I plug in negative, is 5 times negative 2 minus 3 times negative 10 bigger than or equal to 10? So I have negative 10 plus 30, that's 20. It is in fact bigger than 10, so negative 2, negative 10 is a solution. Try the other two. All right, so now when we're looking at graphing inequalities, I want to graph the inequality y is less than 2x plus 1. So if you remember in the past, we knew that we had solid versus dotted lines. In this case, it would be dotted because it's not or equal to. So I'm going to graph the line 2x plus 1. And I'm going to connect it with my dotted line. And then since it says y is less than, that means I'm going to shade underneath the line. Or you can plug in 0, 0 and see that it does in fact make a true statement. So I shade where 0, 0 is, which is on the underside of the line. Okay, for the second one, I'm going to solve it for y. So I have 4y is greater than or equal to negative 3x plus 8, and then divide by 4. So that gives me negative 3 over 4x plus 2. Now, since I divided by a positive 4, I don't need to flip the symbol. So I'm going to graph the line. I will make it solid in this case. Since I have or equal to. Okay, so I have a solid line, and since its y is greater than or equal to, that means I'm going to shade on the top side of the line. Or you can test by plugging in 0, 0 to see if it makes a true statement, which it does not. So since 0, 0 is over here and it's false, then I shade on the other side. All right, so let's just look at a couple more of these because these should be review. Okay, so I'm going to look at A and B here. I'm going to solve this for y. So I'm going to have 2y is less than negative 6, and then divide by 2. So I get y is less than negative 3. I leave the symbol the same because I did not divide by a negative. Negative 3 is y equals negative 3 is a horizontal line, and since it's not a less than or equal to, I'm going to make it a dotted line, and I want all the y values smaller. So that means shade underneath. And last but not least, let's look at a vertical line, x equals 2. This one's going to be, we're going to pretend that's straight, sorry. Vertical line, and I want all the values for x that are bigger than 2, which would be on this side. All right, so this is, so now if I have a system of linear inequalities, that means I have 2 or more inequalities, and to solve, that means that I have a point that satisfies all of them together. So graphically, what we'll be looking for is where does the shaded region overlap for all of the inequalities that are included. So let's start with a system of 2 inequalities. I'm going to graph each of them separately and then look for the shading overlap. So I'm going to start with the negative 2x minus 5. So I'm going to go, since I can't go down any farther from here, I'm going to go up and to the left. And I've got a dotted line, and it looks like my shaded region is above since its y is greater than. And then I'm going to change colors here. Let's go with red. Okay, so now I've got x plus 3, so I'm going to start at 3 and go up 1 over 1 and down 1 to the left 1. And so on. This one's solid, and it's less than or equal to, so that's going to be underneath the line. So what I see is my shaded region is this region here. So solutions to this would include anything that's within this shaded region here, and anything that is on the portion of the red solid line that touches that doubly shaded region. The dotted line are not solutions. Okay, so let's look at the second one. I'm going to solve this for y, so I have 2y is greater than negative x plus 4. So that's going to give me y is greater than negative 1/2 x plus 2. Okay, so I'm going to graph the dotted line. Down 1 to the right 2, up 1 to the left 2. It's going to be dotted line, and I want all the y values that are greater than. And then change colors. Let's go with the purple. So I've got negative 1 and a slope of up 1 over 1. So now, before, what we were looking for is where two lines intersect for our solution. Now we're looking for the places where the shaded region overlaps. So I've got y is less than, so it's going to be underneath the line. So my shaded region for my solutions is where they overlap. Okay. So I want you to graph these two. Now remember, for this example here, when I solve the 3x minus 4y is less than negative 8, you have to remember what happens when I divide by the negative 4. So I want you to graph these for yourself, and then I'm going to give you a point, and you're going to tell me whether or not it is in the solution region or not. Alright, so let's look at a couple that are a little bit more complicated. So we're going to look at y is less than or equal to 3, and then we're going to look at absolute, so we're going to get absolute value. So we're going to get some review on absolute value graphs. So the first one, y is less than or equal to 3. That means I have a horizontal line. This one's going to be solid since it's or equal to, and I will shade underneath the line for all the values less than. Now for the absolute value, I have a vertex at negative 4, 0, and it has a slope of 1. 1, 2, 3, 4. And so I'm going to go up 1 to the right 1. And it's a solid V because it's or equal to. And just like the line, since it says y is greater than, I'm going to shade above the V, which means it's going to be on the inside. So the only place where this overlaps then for my shading, it's a little hard to see, but it's this little triangle in here. This region here is my solution region because that's where they overlap. So we're going to continue with this in class next time. What I want you to do is graph each of the three from example 4, part A. You're going to graph each of those and find where all three regions overlap as your solution. The rest of them we'll do in class next time.